Okay, so let's take a look at segmentation. Once our policy is the way that we want it, or the way that we think we want it, once we've validated it, we can now essentially achieve our goal, which has been segmentation. Now, our goal the whole time is to achieve segmentation. Our goal the whole time has been to take something that's incredibly complex and make it as simple as humanly possible. So we want to understand the application, we want to validate that that policy is in fact correct, and then we want that single button push. We want that really simple way to segment our network. This has been a huge challenge within my customer base because we don't know where to enforce those policies. Do we put them on a firewall? Do we put them on a distributed firewall, a virtual firewall, a physical firewall? Where do we put them? And who's going to manage all those rules? And how are those segments going to be? How do they interact with each other? All those kinds of things. I mean, segmenting your environment with a distributed firewall looks great on paper, and it does really work when you're talking about different segments within an environment. So maybe keeping different VLANs from talking to each other, or keeping different subnets from talking to each other, or maybe keeping different groups from talking to each other. Where distributed firewalls and any kind of firewall really doesn't work, and where Tetration really shines, is firewalls aren't really good with keeping individual servers from speaking to each other at scale across your entire environment. I mean, you're not going to go and create 10,000 network objects in your firewall, or any firewall, and expect to manage all of that and do all of that easily to say, hey, this web server can only talk to that database server on that port. And so this is something that Tetration does really, really easily. Now, what's really cool is that Tetration can now take our policy that we've generated. Hey, do we want to allow this traffic, or do we want to block it? What are we going to do with it? Tetration can take that policy and enforce it down to the workload on any infrastructure, right? So regardless if you're running Cisco, Arista, Juniper, doesn't matter, we can enforce that policy. Regardless where you have that workload living, maybe in the cloud, whether it's EC2, Google, AWS, doesn't matter, we can enforce that policy. At the same time, we realize that you may have other enforcement mechanisms. So again, maybe you do have a firewall between segments, right? So we'll just say seg1 and maybe seg2. Maybe you do have a firewall between these two segments, and maybe you want to leverage some of those policy items within Tetration and leverage that firewall to actually block traffic going back and forth. Tetration has an open API where you can easily use a tool like Tufin or AlgoSec to actually reach into Tetration, take that policy out, and then enforce it on a physical firewall. In fact, both Tufin and AlgoSec have written to our API. In fact, I think AlgoSec listens to our Kafka bus, which is something I'll mention in a minute, listens in on Kafka to actually stream the policies out onto your physical firewalls. So these are things that you can do today. Tetration also integrates with its own firewall. So if you have an ASA, for example, you can use Tetration to orchestrate the policies on an ASA. But again, regardless where you want to do that, Tetration is not just a system that marries you to enforcing a policy a certain way all of the time. We don't want you to be locked into doing things our way. We want you to be able to do things the way that makes sense for you and your organization. And we want you to be able to leverage this tool where it makes sense for you and how it makes sense. When you enforce policies within Tetration, all of those policies are not just streamed out to the workload, but they're also sent to a Kafka bus, again, where AlgoSec is listening in. So you can have other systems that listen into this, that listen to Kafka and essentially say, hey, I just saw a new policy posted. I'm going to go in and maybe submit that to a change control system, etc., and go down whatever process makes sense for your business. Our policies can also be exported in 3 formats. We support JSON, we support XML, and we support YAML. So you can take our policies, you can download them, export them from Tetration, you can normalize them in any way that makes sense for you and your organization, and then you can go ahead and you can enforce them any way that you like. Of course, the real easy way is just hitting the big green button within Tetration to say, enforce me now. Now, how does this actually work? Keep in mind that keep in mind what Tetration has been doing this entire time is compiling all of our data into one place, right? It's trying to make a consistent security policy across your infrastructure. But what's interesting is that we can use our knowledge of our environment in our policy. For example, allowing an application that's labeled HR to use a shared database, right? So perhaps we say, look, if we have an HR system, HR is allowed to see specific shared database environments, allowing maybe non-production from ever reaching production, right? That's a really simple one, right? So here, if I'm saying, look, non-policy or non-production, you're not allowed to see production applications. And Tetration can convert that information into IP to IP. So the rule is always going to be IP to IP, but the point is that now I can give my human intent to my policy, right? So example, if I allow HR applications to use the employee database, as long as that application belongs to HR, it's allowed to use the employee database, right? But now here's one that really stands out to me, and I actually really like this one. Blocking all HTTP connections for servers that are not web servers. How do you do that today? Without actually knowing what is and what isn't a web server, how would you do that today? Well, Tetration can easily do that, right? If it doesn't see that it's a web server, if we don't see the right services running, if we don't see the right packages installed, if we don't see, if they're not labeled correctly, whatever criteria we want to throw at this, if Tetration doesn't see that criteria met, then it will not allow port 80 traffic into those servers. And of course, as I said, Tetration will translate that down to IP versus IP, but now I'm actually delivering my intent. I'm telling Tetration what I expect it to do by either blocking production from seeing non-production, allowing HR to see the shared database, or blocking web connections to servers that are not considered web servers. So I can easily do these policies within Tetration. So let me pause the video. We'll jump into a lab where we're going to take a look at both the policy analysis and the segmentation. All right, so let's jump into the lab. Let's actually see how Tetration can segment an application. Now, I have multiple workspaces here, and we're going to dive into these in just one second, but I want to dive into specifically policy analysis. Before we segment anything, before we actually go ahead and lock down an application, we want to make sure that our policy is, again, correct. So let's go click on our demo app. And you can see that I have 25 policies here that have been generated for me. I have my database tier, so I have my clusters. We went through how Tetration builds these out. So I have my HA proxy servers for my web proxy, my database proxy, and I have my 6 servers in this particular application. I have my DB tier and my web tier. And again, 25 policies that have been built out for me based on how this application acts, based on the resource utilization. I have my domain services, IP address management. So Tetration has gone ahead and mapped this all out for me. And again, it's done this based on CMDB integration, load balancer integration, integration to various different other products that we have, vCenter labels, etc. And Tetration's kind of put this all together for me. I'm going to come over here to policy analysis. Again, this is key to understanding whether our policy is correct or not. Now, Tetration has revision control when it comes to different application mapping runs. So for example, if I tell Tetration to map out an application for July and I ask it again to map out an application in August, I'll be able to see the different versions of the different policies that I went ahead and mapped out. Now, what I'm interested here is the rejected traffic. So I don't want to spend a ton of time going through the different categories. You can see here that Tetration can look at what packets are being permitted, rejected, what packets are misdropped or escaped, meaning policy violations. We'll just leave it there at a high level. But what I want to see here is just the rejections. So what I'm going to do is I'm going to unselect the other 3 categories and just leave the rejected packets. And you can see that Tetration, based on a 5-minute interval, is going to start telling me how many packets were rejected at different points. I see a pretty heavy hit here. I see 631 packets, and so I want to go ahead and dive into what that might be. So the first thing off the bat, obviously we see that they're all rejected. We see they're from an unknown host name. So we don't know the host name. We can see that we don't have an agent that lives there on this particular agent. Now, this is one thing that people ask a lot. When you deploy Tetration, do I have to have an agent everywhere? The answer is no. Right now, we have agents living within our application. So I have agents on the web server, database servers, etc. I don't have an agent here. Yet Tetration is still seeing the inbound traffic. It's still seeing what is being used. It's still seeing the source destination protocol. It's still seeing the services on the agent side that are attempting to be consumed or that are running. Now, a couple things right off the bat. I'm noticing here that this is obviously a database server. This is dbserv 1776, good year. And I'm seeing that the protocol is TCP, the provider port is 53, and the service is DNS. I'm looking at the provider being the database server. So what I'm seeing here is an unknown server that does not have an agent. The IP address is 1.14, 172.16, 1.14, and it is trying to consume DNS services on a database server. I'll stop for a minute and let that sink in. We have an unknown source trying to hit my database server with DNS queries, and we see it quite a bit. That's not okay, right? So it looks like we may have something in our environment that could be trying to do a scan. It could be misconfigured. Maybe we upgraded our database server and reused an IP address that maybe we shouldn't have used. I mean, the reasons why this could be are endless, but it's the fact that this traffic is in fact going on, and we see it clearly. So this to us, if we implemented this policy right now, first it's important to know that right now this traffic is actually happening. Right now our database server is being queried for DNS. It may not be answering because it doesn't have DNS services running, but this server is hitting it for DNS queries. And our policy would prevent this. Let's keep scrolling. Here's another one, very interesting. I'm seeing the same source, 1.14, that's hitting the same database server with remote desktop. So is there something that is misconfigured on this endpoint? Is this endpoint 1.14? By the way, I didn't do this on purpose. I just deployed this application, ran a scan, and clearly we have something going on. So is this something that's misconfigured? Is this something that I need to go fix? Is there something wrong with my policy? Or maybe my database server? Should my database server be running DNS? These are all things that now we can start to go ask ourselves and say, hey, is this normal or is this not normal, right? It doesn't seem like it should be normal, but clearly we have some issues. Now here's something else that's interesting. We see rejected traffic from NTP. So we see that I have my web server, my database server, it's trying to reach 1.91, 1.91, 1.90, and it's trying to leverage NTP services. This could be something that's actually normal, right? It looks like something's trying to SSH into my database server. Again, that 1.14. So I'm going to not allow this, but maybe these things here are very normal. Maybe these things here are NTP queries that my application requires in order to function. And I want to make sure that I don't deny that. So I can go and I can add this to a policy if I want to. Now here's something that's really cool about Tetration. Tetration remembers your data for typically up to a year, depending on how much data we give it. Typically it's up to a year. Sometimes it could be longer. You can see that this is an underutilized lab. So right now the max in this particular cluster is 2 years. Imagine being able to run a policy on a very critical application and have it in analysis mode for a year or 6 months and say, you know what? We need to make we need to be extra careful that we do not break this application. So we're going to run the ADM, we're going to run the policy generation query, right? We're going to run our ADM for 30 days, and then we're going to leave it sit there for half a year. And we're going to look at all these rejections. We're going to get alerts and alarms, and you can manage these alerts here. I want to manage these alerts. I'm going to go ahead and create alerts every time I see rejections, and I'm going to go and take a look at what those are so that we're absolutely positive that this application functions as it should. Here's another thing that we can do. I don't have to just leave this based on, again, the top talking host names. I can sort this by process, and I can say, okay, Tetration, can you show me what the heaviest process is? Again, based on where the agents are. So down here, I could say, you know what? Just show me the MySQL processes. So just show me where we have any rejections in database traffic. So show me right here, I had 2 packets that were rejected. Well, here's that same host again, 1.14. Maybe I'm not going to go ahead and add this to my policy, but I could if I wanted to, or if I investigated it and said, you know what, this is something that happens every other month. That's why it's not included in the policy. That's why it's not included when we last ran it, because it runs only once every 2 months, and we missed it. Clearly, we're seeing that these rejections would take place, but we need them. Let's go add this to our policy. So this is a really, really awesome feature within Tetration to verify that your policy is in fact correct. And again, you can go back long term. So you can say, hey, we generated the policy today, go back to April or go back to January, and let me see what this policy would have done if I had it in place. Would it have prevented that attack? Would it have saved me from being compromised or not? Should we have put this in place earlier? Or again, we can put it in live policy analysis mode to be able to get alerts and to be able to get, notification when we see rejections. So it's a really cool feature. I'm going to go ahead and I'm going to start enforcing some of these policies. So I'm going to come back to my workspace. I'm going to go to my global policies. These, again, are policies that are going to go across my entire data center. So I'm going to come over here to my absolute policies. Let's take a look at these really quick. I showed these in another video, but in case you skipped it. So I have production services. Here I see my 8 servers that are in my finance application. So my database servers, my web servers, and they can only talk to other production servers. So prod can only talk to prod. Keep in mind that Tetration is a whitelist. It's a zero trust application. So if we don't specifically trust it, Tetration will deny it. So my catch-all is deny. So prod can only talk to prod. Prod cannot talk to dev. Dev cannot talk to prod. Only production can talk to production. P2, same application. So in this case, anything that has P2 equals true, that's all I'm going to allow to talk to. So only P2 can talk to P2. Then I have some of my management tools like Guacamole and Ansible. They're allowed to see the resources within the data center. Obviously, I want them to be able to manage the resources, SSH and remote desktop. I also have authenticated users. Now I have 7 machines in authenticated users. One of them is a VDI machine. One of them is an app proxy that I have. It's a load simulator. And these are based on 2 different queries. So if the ICE group is an employee or the environmental tag from CMDB is an authenticated user, then we're going to go ahead and consider it a successfully authenticated user. Keep in mind it's one or the other. So if we've already labeled it in our CMDB or that person logs into our infrastructure and ICE puts them into the security group called employee, then we're going to allow it access to the data center. Then the last thing is the IoT devices, right? All based on ICE security groups. So if the SGT in ICE is IoT, if it's MDM compliant, and if it's not jailbroken, then we're going to consider it an allowed IoT device, and we're going to allow it access to the infrastructure. I'm going to come here to my enforcement tab, and I'm going to say enforce policies. Now, Tetration does have revision control. So I have enforced this policy so far 5 times, right? I just did this 5 times. You can look at the dates. I've just been doing this over the past couple days, or couple weeks. So if I go ahead and click number 5, that's the 5th revision, I'm going to say accept and enforce policies. At this point, what Tetration will begin to do is actually allow these policies to be configured on the endpoints themselves. But I also want to configure my demo app. Now, before I do that, we have in our lab, what we did was we took Nmap. Nmap is a free scanning tool. This tool allows you to see what vulnerabilities, what versions of software, what ports are open on various different endpoints. And I went ahead and ran this beforehand on my application. So if I just select one of these, I can see that I have a server in my infrastructure that's running OpenSSH version 7.4. It's a web server running Nugenix 1.16, and it's also an HA proxy box. If I click another one, let's go to 241. I can see that this is a web server running not just Nugenix, but it's also running Apache, so we have both. And again, OpenSSH. So all I need to do, if I was an attacker after running this kind of scan, I would go in and I would say, okay, well, what vulnerabilities can I leverage to attack this endpoint? So I've pre-run this to just show you that this is essentially what an attacker would see in your environment. So what I want to do is I'm going to come over to my demo app, and I'm going to go ahead to enforce this policy. So we'll click enforce policies. Again, with the revision control, if I've pushed this down multiple times, or if I had different versions, I would be able to go back in time or go back to a different revision. So we're going to say enforce these policies. So now if I go back to my main workspace, you'll see that I have multiple policies being enforced. I have one at my global infrastructure, my global policies. These are very, very high level that can quickly blanket my infrastructure. I'm also going to go ahead and enforce my VDI policy. So let's go take a look at what that looks like. So my VDI policy is very, very simple. So I'm looking for specific VDI software. In this case, I'm looking for Avast, antivirus, and VMware tools. So only Windows 10 machines that are software compliant, that have the right antivirus version and that also have the right VMware tools version, are allowed to access the data center. If Tetration does not see that you have these 2 pieces of software running, again, this is based on the process hash of that software. If it doesn't see that you're running antivirus and VMware tools, you're not allowed to access the data center. The last thing that I'm doing is I'm allowing any machine, any VDI machine, to leverage Google DNS and also ping Google, right? And this is going to be based on operating system being Windows 10 and the host name containing VDI. Again, I don't care if somebody misnames the machine. As long as VDI is somewhere within the host name, we're going to consider it VDI. So I'll come over here to my enforcement tab and I'll go ahead and click enforce, and I will go ahead and say accept and enforce. So very, very quickly, within the matter of a couple minutes, I have now segmented various different pieces of my environment, and I've done it very easily, very simply. And this again could be 5,000 policies to Tetration. It doesn't matter what it is to Tetration. It matters to me as a human being. I don't have to manage 5,000 policies against, against 25 firewalls. I can now make Tetration do all that heavy lifting. I'm simply making my will known. What I'm going to do quickly here is I'm actually going to go into my demo app, and I'm going to just pick one of my servers. So let's go to the database tier. Let's randomly pick one. We'll pick server 81. And I want to look at the policies that are actually being downloaded to this particular endpoint. So I'll go to policies. It is a pull model, by the way. It's not a push. So what will happen is when the agent checks in, the agent will download any new policies for it. But you can see here that I can now see all of these policies. Actually, let me say fetch all stats. So you can see here all of the policies that are now implemented on this endpoint. You can see the ingress and egress. So essentially you see the direction of traffic. Tetration is really good at letting you know exactly what those filters are. So we're going to allow authenticated users to any port. We're going to allow prod to anything. We're going to allow anything to talk to prod as long as it's prod. So, you can easily go through and you can see all of the different policies that are being implemented on this endpoint. But what's also cool is that as we fetch the traffic stats, you can see how many times these rules are actually being utilized. So think about how many times you have stale rules in your infrastructure and you're not able to see whether they're actually being used in an easy way. Right? You don't want to have to go to 30 firewalls examining 3,000 ACLs. You want to be able to see quickly, okay, are these rules stale or not? This is a really quick, easy way that we can do that because we're actually showing that, hey, you have 0 bytes, 0 packets that have ever hit this rule. Does it really make sense for you to keep it? Right? So we can show you that. Now what I'm going to do is I'm going to come over here to my Nmap and I'm going to rerun this scan live. Right? So let's go ahead and say scan. We'll hang out here for a minute and just talk about the weather. I'll just try to make the time go. And look, it comes right back. What's interesting here is that Tetration has now completely segmented my application, where before, as our attacker, we were able to see all the open ports, we were able to see all of the servers. I am no longer able to actually see this application as a random attacker. But what about being able to see the application as a whole? Can we still use it? Well, let's check. So over here, I have my jump box. Now, I've already logged into this application, so what I'm going to do is I'm actually going to go ahead and copy the IP address. I'm going to close down Chrome, and let's go back into it. So let's go ahead and let's pop in that IP address back. Let's relog into this finance application, if I can remember the password. And let's just start clicking around. Let's start opening up some invoices. Maybe we can delete one. So you can see that now our application is completely hidden. We've quarantined it, if you will. We've only allowed certain users to be able to see it. Again, authenticated users based on ICE and based on also what we've tagged in our CMDB as being an acceptable campus subnet. So only our authenticated users are able to see it now, which this jump user is. But the user or the subnet where this traffic is coming from, this Nmap scanner, is not allowed to see that application because he's not an authenticated user. So now we've actually completely hidden that application from view. We've enabled ourselves to completely segment not only our VDI environment, but also our finance environment, as well as push down global policies to our infrastructure without making a modification to a router, a switch, or a firewall, without changing our cloud infrastructure, without having to do layer 2 stretches across different infrastructure, without being married to a specific hypervisor. This didn't matter. All we did was click a button that said enforce, and Tetration was able to completely hide our application from view, but also still maintain its usability. So in the next video, guys, I really hope you guys enjoyed this one. In the next video, we're going to take a look at our last section, which is some advanced security capability within Tetration. See you guys in the next one.